All right, I think I am live now. Good afternoon, Professor. My name's Jose Benales. I am in your CSC607 course, Security and Computing, here at National University, completing my cracking Wi-Fi project for the course. So what I'm going to be doing is go and give you an overview of our assignment, what we were supposed to do. Then we'll give a quick overview of the web encryption algorithm, the WPA encryption algorithm, and then go through how I set up my project here at my home. Give you a quick demo live on my computer, or try to, for you, and then go through our results that we did or that I did. I'm sorry, I'm the only person in the project, by the way, that I wasn't in any group. But the cracking that I did here, hold on, and then go through the results and my conclusions. So let's see, the next slide. So we had to crack WEP 64-bit. We had to crack WEP 128-bit as well. We had to use weak passwords for WPA and crack that. I used guess instead of crack because we did a dictionary attack, which is really guessing the password, not necessarily cracking it like I did with the other two. And then I attempted to crack a WPA strong password. Can be crackable, however, with the techniques that I used, it was not. But it's only for strong passwords. Go through the little demo that I'm going to set up, which is just a brief 64-bit cracking, and then go through our results, which tools I use, techniques, procedures, and then my findings. So to go through a little bit of the wireless, the wired equivalent privacy, WEP encryption. This was developed later in the 1990s as a replacement to the wired Ethernet protocol. So they wanted to use or invent something that was over the air, a wireless protocol, WEP. With this protocol, there was a 40-bit and 104-bit encryption key. They used both open key and shared key protocols. They were both oops, there was a typo on here actually. There's two different key sizes. The 64-bit is the one key size, which is 24 bits of the initialization vector and 40 bits of the key. The second key size is actually not 64-bit, is 128-bit, and that is 24 bits for the initialization vector and 104 bits for the key. So I'll have to make that change. The key does encrypt the packets using the key and the initialization vector combination using the Rivest Cipher 4, which is a streaming cipher protocol, and it creates a key string. One of the things that was that they needed to take into consideration was the key stream couldn't be repeatable. Otherwise, crypto analysts can decipher that key fairly easily and quickly. So what they did was do an XOR operation on the key with the initialization vector and the actual key to create that key stream. And what was changing was the initialization vector to create a different key stream with a same key. That way you wouldn't have multiple duplicative keys being sent. So that was the thought process behind that. And so now they were able to get a ciphertext from a plain text message with this key, encryption key. And there was an issue with that. The issue was that they concatenated, or they combined the initialization vector with the ciphertext, but the initialization vector was in plain text. So on the next slide, you'll see kind of a little graphical views of the way that these keys are set up. So there's a 24-bit key or 24-bit individual IV combined with a 40-bit WEP through the RC4 algorithm, and that creates the key stream. Then the key stream gets XORed with the plain text to create a ciphertext. So now that you have the ciphertext, in order for the receiver to decode it, it needs the IV along with the web key that they have, right? They already have the web key. They just need the IV so that they were able to decrypt the message. So what they did is the IV was actually sent to plain text over the air through the transmitter. The receiver receives this ciphertext with plain key, and they're able to extract that and again XOR it with their web key, RC4, decode it, and go back through the ciphertext or the plain text. The issue with this is that now hackers can also listen to these IV packets over the air, and if collected enough of them, they are able to extract the web key from a huge collection of IVs, or be able to guess the web key from a small collection of IVs. And I'll go through that here in a second. But that is what it is. There's also a frame controller, CRC cyclical redundancy check. It's part of the packets to ensure the integrity of the message being sent. So this is kind of a standard process for WEP, and they have several vulnerabilities. The IVs are in plain text. They reuse keys, although they do avoid some redundancy on the key string, but they do reuse them. There's a linear checksum. There's no key management. It's part of the WEP. One of the huge issues is they're susceptible to the ARP replay attack, which is the one that we're going to use to crack this WEP. And of course, the WEP key is static, so it doesn't change. You can change it, but then you're going to have to change the encryption and the key to get into the access point. So those are some of the vulnerabilities. So some of the exploits is we're able to capture the packet, look for the specific ARP request. Once you have an ARP request captured as part of your data collections, you can actually induce more frequent IVs by replaying that ARP request to the access point. Doing that, then you collect more IVs so that you're able to have more data sets and be able to crack that. Now, again, you can use less IVs if you use the dictionary attack online, and there's other places where there's huge databases of common passwords or different combinations of passwords, and you can use dictionary attacks to guess what the key would be given some small data set of IVs. What we've also done is we actually just did a brute force attack, collected enough IVs, and we're able to crack the WEP. And I'll show you that here in a little bit. Other attack vectors that can be used with WEP is you can use fake authentication with the access point. You can query new IVs, or you can just have a Wireshark or arrow dump open, collecting IVs without even inducing anything. As long as there's enough activity on the network, you'll be able to collect IVs. WPA was an improvement on WEP, of course. They had three forms of protection, if you will. They had the temporal key integrity protocol, message integrity codes, and the 802.1 authentication process to be able to better encrypt the messages and the network. The TKI protocol is also based on the RC4 algorithm, and it's a combination of a shared key, the MAC address, and the TSE, which is the packet sequence number. Excuse me. The message integrity codes are actually a whole bunch of partition messages that produce a 64-bit output. And these partition messages are mixed together with different key functions, such as XOR bit or bit swap or additions. And so it's able to scramble some of these messages. And then you also have the extensive authentication protocol, EAP, that is used by the 802.1 to create mutual authentication. So with these three improvements, then you're able to defeat message forgery attacks, reduce replay attacks like the ARP replay request that was available in WEP. And then you can send, instead of sending the IVs in the clear to be able to decrypt, the encryption, the TSC is actually better encrypted with these mixed messages and authentication protocols and two-phase mixing of the numbers of the bits, sorry, that you can send it in the clear without having to worry about being able to get the key from that, since it's not dependent on each other between the TSC and the encryption. So WPA definitely had an improvement on WEP, but there were some issues and some recent vulnerabilities that have been developed. So what I'm going to do now is I'm just going to go through and give you a overview of the setup. I was able to use a target access point on the TP-Link Archer C50, which is right there in the middle. It was just a standard router, was able to do WEP, WPA encryption on it. So perfect for this project. For the Wi-Fi attacker, I actually used my desktop PC, and I was able to get a wireless network card that was able to go into monitor mode and able to transmit packets, which is the AWS 0360 ACH, the alpha card. So that was I got that just specifically so I can do this project. And then for the Wi-Fi clients that create the traffic on the background, I just use Chromebooks that I had here to be able to generate that traffic. So that's the hardware. For the software, on the client, which is all the Chromebooks, I only had a script to generate traffic, so I don't have to keep, going on websites or anything like that. It just automatically refreshed and created traffic. On the attacker side, I used the suite of tools, so pretty much installed Kali Linux and had all the tools that I needed. I added a few other ones to be able to complete the suite, such as Xtools, but I'll go into that here in a second. I also was able to use Windows when I first started, and I'll go through this in my challenges, but when I first started, I also used Windows, Wireshark, and ComView to be able to do a dictionary attack on the 64-bit web. But I'll go through that here in a second. So that's my project setup, my software. So the way that I use these tools is I essentially needed to monitor the network, and the tools that I used for that were 3 of them. It's Wireshark, and I use Wireshark specifically in monitor mode because you can save it as a capture file, and that capture file can actually be ran through the air crack and crack the password, the WEP encryption with that capture file. So I was able to do that on Wireshark. I was able to do it on ComView, but the ComView, I did it using a dictionary attack. So again, collected IVs, got the capture file, stored the log file, used aircrack, and was able to use a dictionary attack with the word list to be able to crack the password. And again, password were, they need to be weak in order to be able to crack them. And then, of course, I used AirDump and AirMon for the Kali Linux to be able to monitor the network and store capture files. So those were the tools I used for monitor. A simple kind of process flow in order to get the attack vector for the WEP. So the first thing I had to do was to configure the wireless card to monitor mode using AirMon. I had to then find the target access point with AirDump. On AirDump, you're able to see the different wireless networks and access points that are available and what encryption they use and what channels they're on and things like that. So it's a lot of good information that provides you that you can use to then collect packets. So now when you're collecting packets and storing it into a cap file using AirDump, which is what I did, is you can set the channel and you can set the MAC address, which is another data point that the AirDump gives you as a MAC address. And so with those 2 data points, then you can start collecting packets from AirDump and storing in a cap file. Once you have enough, in order to be able to effectively collect those packets, you want to make sure that you're authenticating your MAC address, and so you use AirPlay to do that. And so that command that you see here in AirPlay, I can authenticate the packets to make sure that my MAC address is associated with the network, and I'm able to collect packets. And then once I'm able to do that, I can collect ACK and ARP packets. I'm specifically looking for the ARP packet so that I can leverage the ARP request replay attack exploit on this network. And so the command that I used was airplay ng tac3, which is the ARP request replay attack on the MAC address for the access point, which is this one, and spoofing this MAC address for my wireless adapter. Once that happens, then I can collect IVs. It'll stimulate IVs. Again, this will just improve the time to be able to get those data collections, because you can just sniff the network without inducing IVs, and as long as there's enough traffic and given enough time, you can collect enough IVs in the network to be able to crack it. But this just helps it to speed it up. And so then once you have enough IVs, you crack the WEP using AirCrack. And so that's the process that I used. The good thing about Kali Linux is that it is a ethical hacker suite, which tends to automate a lot of these processes. So there's two commands or two programs that can be used to automate. BSSIDE TAC-NG is one, as part of an AirCrack suite. And then Wi-Fi is actually another one. You need hex tools and pirate to be able to use this one, but that's another tool. So these two tools, you can just automate the process that I described before, which was pretty convenient for this project. So before I go into this, let's see if I can just run a little demo for you and see if this works. Hopefully you can see the screen. All right, so this is my actual virtual machine of Kali Linux. I am going to show you my configuration. You'll see that it's in managed mode. I want to put this into monitor mode. So the way that I do that, then I have to use air dump. And so I go here, and then that'll actually give me a, I should have used air mon. I'm sorry, but air dump. Here you go. You get what's on there. So this is our target right here. Is what we're trying to find. Is this net one. All right. So let's check IWconfig again. All right. So now you see it's in monitor mode. So AirDump actually did put it in monitor mode already. So once you have it in monitor mode, let's see what channel that target network is on. So it's on channel 1. So we want to put this network card on channel 1. And so right now it's actually not on channel 1. That's not the frequency for channel 1. So the way we do that is we use this command right here. And so that'll put it on channel 1. And we can, we can just make sure that it works. And so there you go. That's the channel 1 frequency. So now we're monitoring channel 1. We can air dump. We can authenticate our MAC address using this command right here. And so this one, it tends to be a little bit flaky. Sometimes it works, sometimes it doesn't. You just have to keep trying it. In this case, the association of that worked. So now we're able to use the BSSID tool to now find these ARP requests. And oh shoot, hold on. Sometimes, okay, so I did this before, and so I gotta clear out my my files here. Good thing is this is on YouTube, so you can fast forward all this stuff if you don't care to see it. But hold on, give me a second here. All right. Just got to make sure. Oh, another thing is I have to make sure that my access point is on and activated, because if it's not, then it's not going to be able to get any ARP requests. So my access point is on, which is my Chromebook here. Now let's try it again. Let's just make sure that this is all good. IWconfig. Okay, it's in the right frequency. It's in monitor mode. Now let's try this again. Right, I think it's playing. So it's going to go through and try to find enough IVs to be able to get that. So now I can go into my client mode and make sure that my traffic is getting enough traffic so that these IVs can go up and I get enough. So it's actually not as easy on the virtual machine because of latency and other issues that I ran into. It's part of my challenges that I'll talk to later. So it actually works a lot better on the on the bare metal equipment, so which I don't have because I'm using my virtual machine here. But you'll see that if you do this enough time, it'll actually crack, and then I'll show you screenshots of that here shortly. So we'll just let that run and see if it gets it by the end of the presentation. But what you'll see is there's a screenshot here, and the way this is right here at the top is my router configuration, and you'll see that it is a WEP encrypted with my key of AAAA in this case, 64-bit. So once it's done and getting enough IVs, it goes in and it tells you it got owned, if you will, the network. And so it actually gives you a hexadecimal value of your web encryption, which is right there. And I translate that hex value over to ASCII, and I know that, oh, there it is. It's my password. I found it. So that's the brute force attack web 64-bit. All right. As I mentioned before, I did do a 128-bit dictionary attack. And that was using ComView. So I installed ComView on my Windows machine here. I was able to download a word list from Kali and be able to use that word list so that I can capture this log file, save it, use AirCrack NG GUI, which is the Windows version of AirCrack, and then be able to then use a dictionary attack on that file. And I ended up cracking it because I used a simple password. Okay. Then this was a challenge. I actually sent you an email about it cracking the 128-bit. So I ran into different challenges because, again, as I mentioned, I was running on the Linux virtual machine, VirtualBox, and that was giving me issues with the driver on the wireless card and other things. So I was really struggling getting IVs. But what I did is I just did a full install on the machine and was able to run it, let it ran, and you'll see here, it actually took, it tells you right here how long it took, 70 minutes and 13 seconds to be able to crack this, whereas the 64-bit took 2 minutes, 1 minute and 58 seconds. So a lot faster by a lot, 35 times faster on the 64-bit than on 128-bit. But again, you'll see that it gave you the 13 ASCII or the 13 hexadecimal value here, converted it over and gave me AAAA. So which is the same as the key. So I was able to now crack also the 128-bit brute force. And then after that, I moved over to the WPA. And again, I used a weak password for the WPA because we wanted to be able to use a dictionary attack. WPA, there are different techniques to doing brute force, which I didn't do in this. I tried it, but it wasn't successful. But with the dictionary attack using a weak password like AAAA, then I'm able to capture a handshake and then go through the handshake and start running the dictionary attack. on it. So to do that, again, I had to have the clients connected and be able to get on the internet and go get the data so that it's able to capture that handshake, just like I did on the web. Once you do that, then I use Wi-Fi in this case for the WPA. Wi-Fi is really automatic, but it's able to capture the four-way handshake and then attack it using the dictionary tag. So worked out. You'll see here that it does show my phase shift keying password AAAAA. So it is right there. Then I attempted to attack the strong password, and you'll see here was a combination of alphanumeric symbols, so definitely tough password to crack. It tried to use the PMKID capture, wasn't successful. Tried to get the handshake, got the handshake, wasn't able to crack it using a dictionary tag, and then at that point it just exited. These are some of the challenges I ran into. Again, started with a standard wireless card on my computer that I had already with the virtual box, Kali Linux. I did it before that. I just did it on the Windows machine with the ComView. I didn't put that on here, but I actually did it on the Windows machine with ComView and Wireshark and Aircraft. And so I was able to do the dictionary attack with that, and that worked fine, as you saw in the previous visuals there. Then I used the standard wireless card with the virtual box, try to do it. I couldn't get the crack. I got the 64-bit crack, but I couldn't get the 128-bit. Then I ran into other issues trying to get that to work. I tried it on my Mac OS, wasn't working on the Mac. I also used Aircrack, didn't work. After research, found out that I just needed to get a different wireless card, so I purchased the wireless card, the one that I mentioned before. Still couldn't crack the 128 wet because I was using the virtual box. Still troubleshooting installation errors, all these things. Wouldn't get enough IVs to be able to replay, do the ARP replay. Couldn't inject enough packets, and left it overnight with just the wire capture. I got up to like 200, 300,000 IVs with just Wireshark leaving it overnight, but still couldn't crack it. I was getting pretty frustrated, sent you an email, but what I did is I just installed it on my desktop, bare metal, with the wireless card attached to it, and then that did the trick, was able to crack the 128-bit web. So that's what it was, my project, exciting project, learned a lot. Definitely, encryption is improving from web to WPA, WPA2, now WPA3 and others. Of course, there's vulnerabilities that'll come to view, such as the recent one that you shared with us. And I'm sure there's other standards that are going to be developed. And that is my presentation. If you have any questions, comments, concerns, please shoot me an email, give me a call, text, whatever, and I'll be happy to answer those. And I hope my video got recorded. Thank you so much for your time.